When three or more lines intersect in a point, they are called concurrent. So if these three lines intersect, they are called concurrent. The point at which they intersect is the point of concurrency. So right here is called the point of concurrency. So the fact that they intersect is called concurrent. The point where they intersect is the point of concurrency. Theorem 5.6 reads, the perpendicular bisectors of the sides of a triangle are concurrent, which means they connect at a point equal distant from the vertices. So the perpendicular bisectors are here. All right, so they connect at one point. They're the perpendicular bisectors because if this is the side, you bisect it, so you cut it in half, and then you make a line that's perpendicular. So if I extend these lines right here, the point at which they connect is right there. When it reads at a point equal distant from the vertices, it means that all three of these segments are the same, equal distant from the vertices. The point of concurrency of the perpendicular bisectors is called the circumcenter. The circle right here is circumscribed. If the circle is on the outside, it's circumscribed about the triangle. The center of the circle is the circumcenter. So there's a lot of vocabulary. So if you have a triangle, draw that triangle, and then you're going to find the perpendicular bisectors. So first I'm going to find where it bisects. And then if I extend and make perpendicular each line, oops, I can't do it very well without a compass, but right here is called the circumcenter. So the circumcenter is equal distance from the vertices. So all of these are equal. I know in my diagram it doesn't look like it, but you can do it better if you have a compass. So down here reads, find the circumcenter of the triangle with vertices at 0, 0, negative 8, 0, 0, 6. So first I'm going to plot these points, 0, 0, negative 8, 0, and 0, 6. So this is a triangle. And we know that to find the circumcenter, you have to see where the perpendicular bisectors intersect. So I'm not going to do this line right here because it's going diagonal, and to find this, the center is a little more complicated, but I can bisect these two. So if this distance is 8, the center right here, the bisecting is going to be right here. If this distance is 6, bisecting is going to be at 3. So if I make it perpendicular and perpendicular, they're going to cross right here. This right here is the circumcenter. So this is going to be the center of my circle. So my circle is going to be made by being equal distant from the vertices. So if I had a compass, I could set my compass to be this long, the pointer right here and the pencil right here, and make a circle. So the circle is circumscribed about the triangle. That's how you find the circumcenter of a triangle. The point of concurrency. So the point of concurrency is where three or more points come together, or three or more lines come together. Of the blank of a triangle is the blank. So down here, this diagram is the point of concurrency of the angle bisectors of a triangle is called the incenter. The circle is inscribed. It's inside. about the, or inscribed in the triangle. So if you have an angle bisector, these two angles are congruent. These two angles are congruent. These two angles are congruent. And you extend that angle bisector, those three lines are going to intersect in the same point, the incenter. And actually, these are going to be perpendicular. So I'll draw a triangle off to the side and pretend that I bisect this, bisect that angle. This would be the incenter. And you could draw a triangle inside, or draw a circle inside the triangle. So down here is another diagram of it. We can tell these are angle bisectors because of these angle symbols right here. And the circle is inside, so right here is the incenter. And the circle is inscribed, it's inside the triangle. So let's review some vocab. Points of concurrency is where three lines intersect. Points of concurrency of the perpendicular bisector, the point of concurrency is called the circumcenter, and the circle is outside the triangle. The point of concurrency of the angle bisectors is called the incenter. Circumscribed means that the circle is around the triangle, and inscribed means that the circle is inside the triangle. So this one would have the center would be the circumcenter, and this one would be the incenter.